Today we're going to be looking at proving angles are congruent, section 2.6. So the first thing we need to do is to define the word theorem. A theorem is just a conjecture or statement that you prove true. And remember, prove means to show that beyond a shadow of a doubt something is true. Okay? So the first theorem we're going to look at, we've kind of already talked about this in class a little bit, but it's the vertical angles theorem. It just tells us that all vertical angles are congruent to one another. So here we know that 1 is congruent to 2. 3. We also know that 2 is congruent to 4. That's the vertical angles theorem. So let's go through a proof of this theorem. So remember, with proofs, we're always given a statement, and then we always have a statement we want to prove. So with the vertical angles theorem, it said that all vertical angles are congruent. A way to write this as a conditional is if two angles are vertical, then they are congruent. So the if part of that statement is always your given. So we're given here that we have two vertical angles. All right? And then the then part is what we're trying to prove. So there we're trying to prove that they're congruent. So anytime you're asked to prove a theorem, just know that that means the if part is your given, and the then is what you're trying to actually prove. So let's go ahead and start on this proof. Remember, step 1 is always going to be your given. So here we're given that 1 and 3 are vertical angles. Okay. And that a reason for that, well, we were given they were. Okay, so let's see what else we know about this. We don't yet know that they're congruent because we have to work our way up to that, to being able to prove beyond a shadow of a doubt that they are. But let's look at angle 1. What kind of relationship does it have with angle 2? Well, they are supplementary, right? So we know that angle 1 and angle 2 are supplementary. But what else? What other angles do we know are supplementary? What about 3 and 2? We know those are as well. So we also know that angle 2 and angle 3 are supplementary. Okay, now we need a reason for knowing this. How do we know that they're supplementary? Well, look at 1 and 2. What do they create? They create a line, meaning they are a linear pair. Same with 2 and 3. They are a linear pair. Okay? So we know that angles that form linear pairs are supplementary. Right? Or you could just say linear pairs are supplementary. You don't have to word it the exact same way as I do. Okay, so now what does that mean? What does it mean for two angles to be supplementary? Well, it means that their measures add to 180. So now that we know they're supplementary, we know that the measure of angle 1 plus the measure of angle 2 is 180 degrees. We also know that the measure of angle 2 plus the measure of angle 3 is 180 degrees. Okay, so what would our reason for that be? Well, you could say definition of supplementary angles you could just say it out that the sum of the measures of supplementary angles are 180. I'm just going to put definition because it's a little shorter. Oops. Of supplementary angles, or of supplementary even. Okay. So now let's look at what we have here. We have two equations that both equal 180. So we know that those equations themselves are what? Well, they have to be equal, right? So we can set them equal to one another. So the measure of angle 1 plus the measure of angle 2 has to equal the measure of angle 2 plus the measure of angle 3. See how every single step that I am doing gets me closer to the goal. Okay, that's what you need to be able to do in a proof. Keep in mind your goal the whole entire time. What are you trying to prove? And that will help direct you. I'm just going to draw down that line there so we have a little more room. Okay, so what property is that? Lets me do that. Well, that would be the transitive property. Okay, the transitive property, you could also call it the substitution property. Either one there really does work. So that one is the transitive property. I know that if one thing equals 180 and another thing equals 180, they also have to be equal. Okay, so now let's see. I want to eventually prove that 1 is congruent to 3. So here, what would happen if I subtracted the measure of angle 2 from each side? Well, that would go away, right? So step 5, we can say that the measure of angle 1 equals the measure of angle 3. And what did we do there? How did we get to that? Well, we subtracted. So that should be subtraction property. Okay. And then last one, number 6, remember we're trying to prove that they are congruent, not that their measures are equal. So we know that angle 1 is congruent to angle 3. Reason there being angles with the same measure are congruent. All right, and that is a full proof. I started with what I was given. I ended with what I was trying to prove. All right, that's what a nice full proof should look like with these. Okay, so now let's use that vertical angles theorem to complete the following problem. Let's see if we can do that. So number 1 says, what is the value of x? So here we have an x in this angle. We also have an x in this one. Well, what do we know about those two angles? They're vertical, right? So those are vertical angles. And we now know that vertical angles are congruent. So we know that their measures are the same. So therefore 3x has to equal that other angle, 2x plus 40. So here, if we subtract 2x from each side, we just end up with x equals 40. So that is the value of x. The value of our angles, the measure of our angles there, would be 3 times 40, or 120 degrees. All right. Okay, so now we're going to look at a few more theorems that are in this section that are pretty understandable. They seem pretty simple and pretty obvious, but they are theorems. We can't actually prove them. So we need to go over those. The first one is congruent supplements theorem. What congruent supplements theorem says? That if two angles are supplements of the same angle, meaning if two angles add to 180 with the same angle, then those two angles have to be congruent. So for instance here, if this measured, let's say 50 degrees, and this also measured, and this measured 130, and we knew that angle 2 was also supplementary with 130, then angle 2 must also be 50, and 1 and 2 have to be congruent. That's what that one says. We also have one for complements as well that says the exact same thing. If two angles are complements of the same angle, meaning they add to 90 with the same angle, then they have to be congruent as well. Okay, so if they add to 90, meaning if this one is 50 and this one is 40, but we know that 3 is also complementary with 2, then 3 has to also be 40. So 1 and 3 are congruent. 2 more that we have, and the first one I know is really silly. And when you are actually using the first one in a proof, you would just state what the theorem actually says, not the number. And that's a big deal. If you ever forget what a theorem is called, what the official name of it is, just state what the theorem says. That is completely okay. It is more important for you to know what that theorem says than to memorize a number. Because in a different geometry book, all right angles are congruent wouldn't be theorem 2,4. It may be theorem 2,8. It may be theorem 2,2. It may be theorem 3,2. Okay, this is just telling you that in the second chapter, this is the 4th theorem. That is all that number means. Okay, it is not in any math textbook ever. This theorem is not 2,4. Okay, it's just telling you for this specific book, it is the 4th theorem for chapter 2. So this theorem just says that all right angles are congruent. And I know that sounds silly, but we'll have to use that sometimes. If we know that 2 lines are perpendicular, we know both of the angles are right angles, therefore we know they are congruent. Okay, and I know again that theorem sounds kind of silly, but we do need it. The next one, theorem 2,5, which again means nothing. It just means that it's the 5th theorem of this chapter. Says that if 2 angles are congruent and they add to 180, then each of them has to be a right angle. Also makes sense, but we're also going to use it. Okay? So we're going to look at one last proof, and we are done with this section. We'll come in and do some work tomorrow. So now we're going to complete this. So we are given that 1 and 2 are complementary angles. Also 2 and 3 are complementary angles. We're trying to prove that 1 is congruent to 3. So this is exactly the congruent complements theorem. We're just proving it now. So this should be a pretty short proof. It doesn't look like it's going to take us that long. So remember, our number 1 is our given. Angle 1 and angle 2 are complementary. Angle 2 and angle 3 are complementary. Reason being, we were given. We have no other way to know that they are complementary other than we were given it in the statement. So what does that mean? What does it mean to be complementary? Well, it means their measures, right, add to 90 degrees. Okay, so the measure of 1 and 2 add to 90. The measure of angle 2 and 3 add to 90. Why do we know that? Well, because we know the definition of complementary. Or we know that angles that are complementary have a sum of 90. Either way you want to write that. What I am going to be looking for is your train of thought, not necessarily how you word something. Well, now look, we have 2 equations that are both equal to 90. So what do we know about those equations? We know they're equal. So we know that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. I really wish that would have fit on one line, but that's okay. That's transitive property. So this one is beginning to look a lot like the last one we did. So now look, both of these equations have the measure of angle 2. So we can subtract the measure of angle 2 from each side, and we're left with the measure of angle 1 equals the measure of angle 3. Okay, so that is subtraction property. All right, and we have one last step. We have shown that their measures are equal. Now we just have to say that they're congruent. So very last step, which will be number 5. This was a short proof, 5 steps. It's pretty good. Is that angle 1 is congruent to angle 3. And we know that because angles with the same measure, whoops, getting ahead of myself, are congruent. And just like I'm using symbols so I don't have to write out full words, I'm okay with you doing that too. I know what those symbols mean. So that is the end of this section. We'll come in tomorrow, maybe do one together as a class, and then I'll let you work for the entire time.